Alright, so we just worked on factoring by GCF, by greatest common factor. So a related factoring topic is factoring by grouping. When we factor by grouping, we no longer have 3 terms, but we have 4 or more, and we'll work on the 4 part. Okay, so it needs to be in standard form. Okay, this squared part makes it quadratic, okay, but it really is a cubic function with 4 terms. So it's in standard form, greatest exponent to least. We're going to group the first 2 terms and the last 2 terms using parentheses. So I'm going to put a parentheses around these first 2 and a parentheses around these second 2. And with those 2 groups, I'm going to talk about a GCF. I'm going to look for a GCF in between those 2 groups. So this 8x squared is the GCF between 24 and 56. Okay, 8's the biggest number. And x squared, I can take 2 x's from each of those groups. Well, what's left is this piece right here. So we will have 3x minus 7, because 8 times 3 is 24, and 8 times a negative 7 is a negative 56, and the variables just follow suit. Okay. The next GCF, okay, you should notice that negative 3 and 7 don't have a number in common other than 1. But that 1 is what's going to be important, because I need to have the negative come out. My x values need to remain positive. So we'll take that negative 1 out. And I had a typo, I'm sorry, so I'm going to fix it here. If I take the negative 1 out, that's going to leave me with a positive 3x and a minus 7. Because when I go to multiply that GCF back through, that's a negative 3x. A negative times a negative is a positive. Well, what you should notice is that my 2 factors left over, okay, were the same, which tells me I've done this correctly. When I factored out a GCF, I was able to come up with the same product. And so we'll write this final answer as a product of binomials, 8x minus 1 and 3x minus 7. We only need 2 things to be multiplied here. So let's look at our other examples. Again, we're going to group the first 2 and the last 2. The number that 21 and 18 have in common is 3. And the a squared. So I'll have a 7a plus 6 left over. Negative 35 and a negative 30. We want to take the negative with it. We want that a value positive. So this will be 7a plus 6. Again, when you redistribute these, you should come up with your original function. Well, if you'll notice, we have the same 2 factors repeat, which is necessary to know we're correct. So we'll write this as 3a squared minus 5, and that's multiplied by 7a plus 6. At the end of the video, I'll show you the answers to 2 and 4, as you'll need to practice those on your own. So if you'd like to pause and practice number 2 for a second, you're more than welcome to. So let's look down at number 3. We still have 4 terms, so we'll still factor by grouping. I'm going to group my first 2 terms and my last 2 terms here. 49 and 42, that's a 7. But as you'll notice, I have an xy and an xa. Well, the only thing in common between those 2 are the x's. So I'm going to take the x out. That's going to leave me with a 7y minus a 6a. Same process will happen with my second 2 terms. Between negative 42 and 36, I'm going to take the negative 6. If you look at the variables, I have ay and a squared. So a is the only thing in common. This will become a 7y minus 6a. Excuse me. Again, these factors repeated, which tells me I was on the right track. So the two factors, the two groups of things that will multiply to be my original expression, my original function, are these two factors right here. So go ahead and pause your video. Make sure you try both of these before you check your answer. And here are the answers. That is a 4. So you should have ended with the same two factors to multiply out to be our original expression. You have several practice problems on the next page. Check your work and try those problems.